In this video, we're going to learn how to solve inverse trigonometric equations. So what is an inverse trigonometric equation? So in equations that contains inverse trigonometric functions. Inverse trigonometric functions are called inverse trigonometric equations. So that's an equation which has some inverse trigonometric functions such as sine inverse, cosine inverse, tan inverse, secant inverse, cosecant inverse, or cotangent inverse. So how to solve such an equation? To solve such an equation, what we can do, we can isolate the inverse trigonometric term. We can isolate the term and take every other terms to the other side and use the definition of the inverse trigonometric functions. So we can use the definition of the inverse trigonometric functions. So let's look at what are those inverse trigonometric functions. So we know there are three inverse trigonometric functions. There are actually six. So these are the three basics ones. So sine inverse, cosine inverse, and tan inverse. So these are the graphs. And then you can see that sine inverse, the range of the sine inverse is from negative pi over 2 to pi over 2. This is like one way to define. You can define this also in different ways, but this is the most common ways to do it. And then the cosine inverse is defined, range of cosine inverse is going from 0 to pi, and a range of tan inverse is going from negative pi over 2 to pi over 2. Sometimes we also call this arc sine, arc cosine, and arc tangent, but we use the inverse definition, inverse notation. And then also for sine inverse, the domain is from negative 1 to 1. That means if you have some value outside of that, you can solve, it's not defined. And then cosine also defined between negative 1 to 1. And then tan is defined from negative infinity to positive infinity. And then, so we talk about the definition of sine inverse. So that means we write y equals sine inverse x if x equals sine y. So you can see that, so it's defined as a like it's defined using the function, because it's just another way to write it. So that means x equals sine y is the implicit version of the sine inverse function. So that means y equals sine inverse x if and only if x equals sine y. Similarly, y equals cosine inverse x if and only if x equals cosine y. And then y equals tan inverse x if and only if x equals tan y. And you can also see that the sine inverse is the range of sine inverse is defined where the cosine is positive. A range of tan inverse is also where the cosine is positive, and the range of cosine inverse is defined where the sine is positive. So that's something you can remember. And then also as the major result, major formula, we can use this ASTC that we discussed earlier. So as you remember, A means all, S means sine, O it's reciprocal, that means cosecant. And then T means tangent, or it's reciprocal, that means cotangent. C means cosine, or it's reciprocal secant. Because when you take the reciprocal, you can see that it doesn't change the sign. For example, we know the cosecant theta is defined as 1 over sine theta. That means it's going to carry the same sign, because when you take the reciprocal, it does not change the sign. So that means the reciprocal have the exact same sign as the original function. Okay, and then so as the major formula, we use f theta equal plus or minus f theta r. Theta r is the reference angle, so that's the reference angle. So to find the reference angle, because there are 4 quadrants, we're going to use let's recall how we find the reference angle. So these are the 4 cases that we have: the first quadrant, and the second quadrant, and the third quadrant, and the fourth quadrant. So let's say the angle is in the first quadrant. So you can see, so this is the angle. So you can see that in this case, the reference angle theta r is simply given by the difference between the angle and the angle on the x-axis, like that. That's the reference angle. If the angle is in the second quadrant, so let's say, so this is the angle theta. So the reference angle is this one. So this is the theta r reference angle. So for example, if you have, let's say 3 pi over 4. If you have 3 pi over 4, the reference angle is pi over 4. Or in degrees, let's say you have 120. So if it is 120, you take the difference between 180 and 120, so that means the theta r is the reference angle is 60. So like that, and if the angle is in the third quadrant, so that's the angle. So you can see, so that's theta. So the reference angle is theta r. So this one is the reference angle. And then if it is in the fourth quadrant, so like this, so you can see the reference angle is that one. So that's always the difference between the angle on the x-axis, the smallest angle on the x-axis, and the angle given. So that's how we find the reference angle. And we also know that the reference angle in radian, it is always in between 0 and pi over 2. And then or in degrees, it is 0 less than 90 degrees. So that's a condition for the reference angle. Okay, so we can use this idea to solve several problems. And before that, now the question is how you can find the values for theta r. For that, we can use the common table that we discussed earlier. So this is the common table, and we can use these values if you want to find the inverse trigonometric function values. So this is the shortcut that we normally use. So those are the values you write from 0, 1, 2, 3, 4 and take the square root and divide it by 2. And you can see that these are the values go to the sine. And then for the cosine, you reverse the order, and the tan is the ratio. And then if you have multiples of pi over 2, we are not going to use these values. What we can do, we can use the unit circle. So we can use unit circle to find the values for multiples of pi over 2. So this is the unit circle for the values for pi over 2. So you use as the if it is a sine, you use the y coordinate. If it's a cosine, you use the x coordinate. If it is a tangent, you use the y coordinate or x coordinate. So those are the basic theories. And let's look at how to solve a few problems. So so as the first problem, so we have solved part A, 3 sine inverse x equal pi. So that's the problem. So asking us to solve for x. So one thing that we need to remember is when you have, like for example, when you write sine inverse x, that means this is an angle. When you write sine x, that means just a value, just a number. So that's the difference between the two. If you have inverse function, those are angles. And if you have just sine values or cosine values or trig values, those are just values. So for this problem, what we can do, as we talked about earlier, we can isolate the inverse trig term. So that means in this case, so the answer, we can write first we can isolate the inverse trig function, So we can isolate that term, in this case sine inverse x. So that means we have 3 sine inverse x equal pi. So if you isolate the sine inverse x term, you can see that this is simply pi over 3. Now what we can do after we get to this level, we notice that so pi over 3 is in the appropriate domain. That means from negative pi over 2 to positive pi over 2. That means we can invert this. We can find inverse function. So by the definition, this means that so by the definition of the inverse function, we can see that this means that x equal, you can say sine pi over 3. So that's what it means. This is just the definition. So what we're gonna do, we're gonna take the inverse of both sides. Once we actually take the sine of both sides. Once you take the sine of both sides, so actually we can write that extra step. So we can say it like that. So we can say we can take the sine of both sides. We take the sine of both sides is sine inverse x equal sine pi over 3. So since x is the value we are looking for, what happened here is, so the sine and sine inverse get cancelled out, so we're gonna get x equals sine y. So you can think of like that. So now what we can do, we're going to find this value. We know that from the common value table, this is sine pi over 3. So sine pi over 3 means square root 3 over 2. So we can write it like that. So that means, so that is the value of x. So that's how you solve the problem. So let's look at the next problem. So as part B, let's try to solve 3 cosine inverse 2x equal, let's say 2 pi. Again, as before, so we can isolate the inverse trigonometric term. That means you're going to divide by 2 both sides. So divide by 3 both sides. So we write it like that. Now what we can do, we can see that if you remember the range of cosine inverse, it was going from 0 to pi, and you can see that that's exactly in that domain, in that interval. Since it is inside interval, we can just write the inverse function because it's in the appropriate domain. So that means if by the definition of the inverse function, you can write this one as 2x equal, just taking the cosine of both sides, you can write this one as cosine 2 pi over 3. So this is just by the definition because the inverse exists. Now what we can do, we're going to find this cosine function, and we know that this angle is in the second quadrant. Since the angle is in the second quadrant, 2 pi over 3, and we know here that this is a common value, pi over 3 is the reference angle. So that means this simply equals to um, you can see this is by, and also by ASTC, you can see this is in the second quadrant. This is a cosine, so it is negative. So that means this simply equals to negative cosine the reference angle pi over 3. That's how we use ASTC and the reference angle argument. We discussed these things earlier. So if you are not familiar with this or have trouble, you can look at that video to find how to find any trigonometric function value for common values. So now pi over 3, cosine pi over 3 is coming from the table, and we know that this is simply 1/2. So that means in this case you're going to get a negative 1/2. Now what we're going to do is we're going to divide by 2. So that means x equal negative 1/4. So that is how you can solve for x. So you can see that we use several ideas that we learned earlier. ASTC helps you a lot. So what we normally do is we simply evaluate. So once you get to this one, so we're going to evaluate this using the ASTC and the reference angle argument. So let's look at the next one. So part C, let's look at negative 6. Let's say sine inverse 4x equal pi. So again, the same argument, we can isolate the inverse trig function. So that means we can see that this is simply sine inverse 4x equal, if you divide by negative 6, it's a negative pi over 6. And then we also notice that negative pi over 6 is in the interval going from negative pi over to pi over 2. That means we can write the definition because this is inverse. So it's in the right domain. So that means so again, by the definition, we can write this one as 4x. If you take the sine of both sides, so we can write this one as sine negative pi over 6. But we know that this sine is an odd function. Since sine is an odd function, we can write this one as negative sine pi over 6. So you can pull the negative sign out because this is an odd function. Sine is an odd function. Now from the common tables, we can find this value sine pi over 6. We know that this is one of the common values, so this is negative 1/2 again. So this is negative 1/2. The reason is sine pi over 6 is 1/2. Now we divide by 4. So if you divide by 4, so you can see x equal negative 1 over 8. So that's how we solve for x. So let's do the next one. So as the next problem, so we have let's say negative 1/2 cosine inverse 3x equal pi. So Again, we can isolate the cosine inverse term. So once you isolate the cosine inverse term, that means you have to multiply by -2. You're going to get cosine inverse 3x equal, if you multiply by -2, you get -2 pi. So now we know that the cosine inverse, the range of cosine inverse is from 0 to, that's the y value, 0 to pi. And then you can see that this value is outside of the range. So that means in this case, you cannot find a x value that gives you exactly this one according to our definition. So that means for this equation, since this value is outside, you cannot invert this one because there are no values that gonna produce, there are no x values that are gonna produce -2 pi x, because everything is in between 0 and pi. That means in this case, there are no solutions for this equation. So because it's outside of the range. So since -2 pi is outside of the range of cosine inverse, I can say x, there are no solutions. There are no solutions to this equation. So there are no solutions because it's outside. So let's do a problem like this. So let's say this is number E. How about this one? Let's say 5 sine inverse x minus 2 pi equal 2 sine inverse x minus 3 pi. And then you can see that there are sine inverse in both sides. Since you see sine inverse in both sides, what we're going to do, we're going to bring it to one side. That means you're going to subtract 2 sine inverse x from both sides. That means you can write this one as 3 sine inverse x. And then you also add 2 pi to both sides. Once you add 2 pi to both sides, it's going to be -pi. Now you can see this is like simple problem as we did before. We can divide by 3. So you can write this one as sine inverse x equal -pi over 3. And then also you notice that this -pi over 3 is in the appropriate domain. So that means we can write the inverse function. So you can write the inverse function as the regular function. That means taking sine of both sides, you can see x equals sine -pi over 3. And again, sine is odd function. This is negative sine pi over 3. So that means pi over 3 is sine pi over 3 is square root 3 over 3. So that means negative square root 3 over 2. So that's how you solve the problem. And as you can see here, we use the fact that negative pi over 3 is inside the appropriate range. Good. So let's do one last problem, a little complicated one. Let's do one with degrees actually. So how about this problem? So with some degrees. So let's say we have 3 cosine inverse 2x minus 1 equal 360. Now in degrees, because we know that the cosine inverse, those are angles. So this is an angle. So again, as before, we can divide by 3. So we can write this one as cosine inverse 2x minus 1 equal, if you divide by 3, so you can see that is 120. Now again, you can see 120, which is inside the appropriate range, because this is 0. 120 is less than or equal 180. So that means in the appropriate range. So you can invert this function. So you can write this one as simply 2x minus 1, taking the cosine of both sides. You can write this one as cosine 120. Now you can see cosine 120, which is in the second quadrant. It's in the second quadrant, 120. So the reference angle is the difference between 120 and the 180. So that means 60. So the reference angle is 60. And then by the ASTC, you can see the cosine is negative in the second quadrant. That means you can write this one as negative cosine the reference angle. but we know that the cosine 6 is 1/2, so you're going to get a negative 1/2. Now, so we have 2x minus 1, so you're going to add 1, so that means 2x. If you add 1, this is going to be 1 minus 1/2, that means 1/2. So dividing by 2, you're going to get 1/4 as the solution for this problem. So this is how you solve several inverse trigonometric equations.